the number of stages in each section of your column. Now, working on the graphs that are provided and are available in your handbook and even in Gianco, please. Okay. Okay. Now, this one was taken from Gianco, please. In the graph, you see that on the horizontal axis, you have the NM and the N. On the vertical axis, you have the reflux ratio R. And on the curves, have values of Rm over Rn plus 1. Now, you know already how to determine the minimum number of stages. So if you have already determined graphically the minimum number of stages, and the problem has provided you with the external reflux ratio, or that's the reflux ratio, then this part of your diagram, the horizontal and the vertical part, are already more or less telling you how to find the N. However, the only way that you can find the N is you know the minimum reflux ratio. Now, how do you determine this minimum reflux ratio without having to rely on the graphing? Because if you recall, so if I may ask, by the way, so if you could still recall, how do you determine the minimum reflux ratio? Or who can tell me how is the minimum reflux ratio determined in the previous set of procedures that you have performed? We're done with the quiz, and this is part of the quiz. How did you determine the R minimum? The minimum reflux ratio, that is?
X prime and Y prime, Miss.
Okay, you will use the X prime and the Y prime value together with the formula that was provided to you. But the previous question to that would have been, how do you determine this X, Y, and Y, X prime and Y prime value? Where do you get it?
Graphing the Q line to the equilibrium curve.
Okay, so that's it. The cross section, the intersection of your Q line or your feed line to your equilibrium curve is the pinch point. And that pinch point will have the coordinates X prime and Y prime, and that you will be using in the formula that is given to you. That way you can determine the R minimum that you will be using here. So let's say, for example, you already have the R minimum and you have the R. You can determine, of course, this ratio NM over N. If you know the minimum number of stages, then the theoretical number of stages can be found. Or vice versa, if you know the theoretical number of stages, you will know the minimum number of stages. But the primary use of this diagram, which has an equivalent, this has an equivalent diagram in your Paris Handbook, is in determining the theoretical number of stages without having to rely on the graphical method. So meaning, if I asked you a while ago how you determine the R minimum, you said you will determine the X prime and Y prime, or that you will use the coordinates of the pinch point. And when asked where will you get the coordinates of the pinch point, your answer is correct. You are to get it on the intersection of the feed line on the curve. However, class, that would be graphical. Now, if I'm going to ask you, if we will not rely on that graphical procedure in determining the coordinates of the pinch point, can you think of another way without having to look for the intersection of the feed line on the equilibrium curve? Will you be able to find the pinch point coordinates? Since this particular diagram, though this is still, shall I say, 5% graphical approach in determining the N, will not anymore rely on the graphical approach that you have previously done in the first part of the distillation slide. So, can you think of a way of finding analytically the coordinates of the pinch point?
Hello, miss.
Would you have any idea?
Hello, miss.
Yes.
Diyan siya. Hindi, pwede miss may-use ang Henry's law kag ang Reyes.
Henry's law and Rayleigh law for the x prime and the y prime. We can't.
Oh,
We can't use the
kaya siya, miss.
How will you be able to use the Henry's law and the Rayleigh's law when the problem in distillation never gives you partial pressures? You have the operating pressure of the steel, but you're not provided with the corresponding partial pressures of the components in your mixture. Rayleigh's law and Henry's law are dependent on these partial pressures. Now, by any chance, have you read the set of pages that I have asked you to read? Okay, so your silence is telling me that probably you haven't read the pages, because if you have read the pages that I have assigned you to read without me asking you the question, you would know already the answer to my question, or you would know how to go about it. But anyway, this is how you find the pinch point coordinates without having to rely on graphing. As we recall, in the graphical approach, the feed line, that is the Q line, and the enriching section operating line meets at the point of intersection of the feed line on the equilibrium curve. So if I have the equation of my feed line or my Q line, which I gave you already, the formula of, and if I have the equation of my enriching section operating line, in your algebra, you were taught that if you process two equations simultaneously, it's just like finding the intersection of two lines. Now, the intersection of these two lines in this case now would be the feed line and the enriching section operating line. That would be your pinch point. So you need not get or read from the graph the x prime and the y prime. But rather, this time you will solve the two equations that I have shown to you. So that's the purpose of giving those two equations to you. That way, simultaneously, you will find the value of x and y, the intersection point of those two lines. That would be your pinch point. Now, if you have already your pinch point, then that answers already the RM here. If you have the RM, you can determine this ratio that you are seeing in this figure. Now, the R is most of the time given in the problem, so meaning you can also determine the Y value on the value of the Y in here on the vertical axis. With that value, you will project to the right and end on the curve, the appropriate curve that you have solved the value of. So in here, you have 0.10, you have 0.2, 0.3, and so on and so forth. So in cases wherein the value is not exactly the ones that you are seeing here on the curve, you will just simply approximate that particular curve, which is represented by the value that you got of the ratio of Rm over Rn plus 1. And that's it. So you project the value of R over R plus 1 to the right, you end on the curve where it will rest on, and then you read downwards on the vertical axis the value of Nm and N. But still, that does not answer the theoretical number of stages yet, because the value that you're getting here is not raw value, meaning it's not yet the N, but rather simply the ratio of N minimum to N. Now, if you will determine the N minimum using the equilibrium curve, you have to know, of course, that you have to have the equilibrium curve given the mole fraction of the distillate and the bottoms liquid. You can do a step-like procedure until you go beyond the XW point. You just subtract 1, that would be your N minimum. That's the easiest way of doing it. But nonetheless, class, that is still graphical. So we don't want to rely on the graphical part again in this part of the procedure. So did you recall anything that we have discussed in the past that will help you find the N minimum? What is it that we have discussed in the first slide that will determine the N minimum without having to do it graphical? Anyone? Na-discuss ta sa first na slide. Ano to siya? Ang gin-discuss ta sa first slide that will determine the N minimum. Yes? It's the what? Okay. Probably the reason why that you have very short-lived memory is you don't read through again what was discussed to you. So you're always relying on the materials available for you to click. Now, if there's nothing to click, yes, Josh? Who was it? Yes?
Amo ning ang Finskis equation.
Okay, so that's the Finskis equation. Thank you. So you will use the Finskis equation. Finskis equation does not rely on the curve, because if you don't have the curve, how can you determine this minimum number of stages? However, the Finskis equation will require you a new value, and that value will be the average or the geometric mean of the volatilities of the distillate and the bottom liquid, as you could see in the formula. Now, there's a sample problem in here that you will read. Everything has already the solution on how to determine the geometric mean of the relative volatilities. That way, in determining the theoretical number of stages, and here you will not have to rely on anything that is graphical in nature, meaning you will have to solve everything. Because in the board exam, you will not do the plotting anymore. So in this case, this is the kind of graph that you will be using. So the essence of having to go through the graphical approach beforehand is to see that the two sections of your column actually is meeting right on the feed line, and it's easier to grasp and understand how the number of stages came about before having to teach you how to do the analytical or the shorthand. The students would normally, the previous batch to you, or the previous ones would say that nga diretsyo na lang tani siya shortcut kay nagdamo pa ang amon nga tulunan. Actually, I would understand why you would want or why would students go straight to the shortcut. But having to go straight to the shortcut without having to understand the principle why the shortcut became the shortcut, for me, does not have any bearing at all. It's just like bottom line is just about the time of having to find the values without really understanding how the values came about. So it is important that even your CMO dictates that the graphical procedure has to be discussed, even though in essence PRC would only measure the analytical way of determining the number of stages. So you will have to use the Finskis equation, and that's it, class. You will know already this theoretical number of stages. And take note, the value that you are getting here is already the value. You need not subtract 1, because this is already analytical way of finding the number of stages. Unlike if you do it graphical, you approximate the corresponding area of the steps that will be covered until only that part of the step until the XW, and then subtract 1. In this case, whatever you read, that's it. That is already your theoretical number of stages. Now, in some cases, I did not include it in the quiz and I did not discuss it in the graphical procedure because I want it to discuss in here. There is this formula that is not relying also heavily on graphical procedure of determining the number of stages in the enriching section. That would be the N sub E here. and the number of stages in the stripping section. Although you will say simply, miss, because it will simply be very simple, miss, because that would simply be the sum of, or these two would simply be the sum of the theoretical number of stages, precisely. But nonetheless, in here, you could see that using only the x of the, what you call this, the high, what is this? The high boiling point component of the feed and the x of the low boiling point component of the feed together with the amount of the bottom's liquid and the distillate. And again, the x of the low boiling component in the bottom's liquid and the x of the high boiling point component of the distillate, you'll be able to get the ratio of these two. Of course, you will simply process the log of this and then get the antilog, you will get this ratio. Now, that's just one equation that gives you the ratio of the number of stages in the enriching section and the stripping section. So you need two equations, right? You need two equations because you have two unknowns. So, of course, the next equation would be what? If this is one equation that gives you NE and NS, what would be the other equation that should contain NE and NS also, that will specifically tell you that this is the number of stages in the enriching section, this is the number of stages in the stripping section? What is that other equation that you will use with this? Since in this case, this one is having two unknowns, number of stages in the upper section of your column and number of stages in the bottom section of your column. What's the other equation that you will have to use together with this? That would be the what? Anyone? If the problem would ask you, for example, in a single problem, all of those questions I gave a while ago will be enumerated, and this will be another question. How many stages do you have in the enriching section, in the stripping section? In your case, of course, you will simply count because you have done it already graphically. But in the case of the board exam, what if you will be asked, what is the number of stages in the enriching section and the stripping section? All you know that you have the total number of stages already using this one. Okay? Now, how will you then determine the number of stages in the upper section and in the lower section? What other equation will you use? I mentioned it already a while ago. What will you use? That way you will have to know that this is really the exact number in the enriching section. This is the exact number of stages in the stripping section. What equation will you use together with this? Anyone? Or base wala lang kamukha hindi? Or base sa lang ako nga pa? Ang ginanamin ko, ini nga equation will give you the ratio of NE to NS. But it's not giving you the exact number of stages in the enriching section and in the stripping section. And you're not doing it graphically. Let's say this is the board exam. So my question now is, what is the other equation that you will use with this? That way you will exactly know the number of stages in the enriching section and the number of stages in the stripping section. How would you, or what equation would that be? Would you have any idea, Katrina? Not the Finskis equation. Finskis equation would simply be used in determining the minimum number of stages. Josh, would you know the added equation together with this? You can solve anything out of this equation.
Hindi ko sure miss kung N equals NE plus NS or...
Very good, Josh. Sometimes ang iban sa inyo kulang sa confidence. Puro sakto gina sa Diyos. Very good. What you will have to do is set up an equation of NE plus NS being equal to N theoretical. Okay? The N that you got here, granting that you know already how to solve for the N minimum, the N that you got out of using this curve, and it's equivalent in your Paris Handbook, you will equate to NE plus NS. So meaning, your extra equation would be the value of the N minus NE is equal to NS. You substitute it in here, so you will get now the exact number of stages in both of the sections of your column. Now, you know already the exact number of stages in the enriching section and the stripping section. If you would be asked, where should be the feed plate located? What will you answer? Or how will you answer that?
Between, miss.
So, if it's between, let's say for example, in this particular formula, I have NE and NS. My NE is 10, my NS is 12. For example, where is the feed plate located?
10 over 22 for NE over N. Those to the dapit, miss. Or
Okay.
naman.
Anyone? Anyone has another answer or has another answer? Let's say for example, NE you have solved to be 10. NS is 22. You would be asked by the board problem, where is the feed plate located? What would your answer be? What would your answer be? Eugene, what would your answer be? You have any idea?
22, miss, ang NS.
Yes, Eugene?
Ilang lagmen.
Ang ginapamangkot ko, basi wala nyo nag-guess, ang ginapamangkot ko, I'm asking the feed plate location. I'm asking the feed plate location. You know already the number of stages in the enriching section, which is 10 in my example. The number of stages in the stripping section is 12. So meaning the total number of stages is 22. I'm asking you, or the problem in the board exam is asking you, where is the feed plate located?
10 from the top.
10 from the top. Who else has another answer? Who is that?
11th plate, miss.
Who is this? I can't see. I'm not having a gallery.
Kenneth, miss.
Kenneth. Very good, Kenneth. Very good. Thumbs up to you. Didn't you? I mentioned that the feed plate is on the stripping section, right? So if your enriching section has already 10, meaning the next stage to that is already the stripping section, telling you that the feed plate location should be the 11th plate. So actually, knowing one value here is already connected to the rest of the questions that might be asked from you. It's just that you have to recall the principle behind of where is the feed plate located. So I have mentioned several times, I think, in the recording, you could listen to that that the feed plate is part of the stripping section. If it's part of the stripping section and if it was shown to you graphically that the upper portion is enriching, the stripping section is stripping, and in between is the feed plate, then it follows that on the upper part, you have the enriching section. Next to that right away will be the feed plate, which is part of your stripping section. So very good, Kenneth. It is the 11th plate, or your feed plate is in the 11th plate of your column. So that's it. You have a lot of questions being asked already out of the several formulas that you have learned in the previous discussion. Any question for now? We will continue.
Pwede man na, miss, magdesimal ang NE or NS.
Magdesimal.
Or like
Yes.
4.6,
Yes.
4.6.
Okay,
For
base ang...
example, we miss
Yes, go ahead.
For example, miss nag 4.6 ang NA mo, so meaning 5.6 amo na sang imo nga start sang feed line.
Oo, imo nga feed plate
Ma plus
are
1 ka gid.
ma plus 1 ka lang.
Ma
Correct.
so
Oo.
sakto.
Mm. Okay, that's a very good question kay hindi tanan nga time ang inyo n whole number. Kag kung read ka mo sa graph, just like miski ginado nyo siya graphically, ang inyo theoretical number of stages, hindi man whole number. Unless nga pag drawing mo, tsakto-tsakto, gid siya digto nagpundo sa XW. But it's very seldom. So what will you do? Your feed plate location in that case would also be decimal. Now, in the board exam, ng paano kung di mo na siya miss ang 5.6 mangitaon kung ang provided nga answer sa amon, puro tanan with decimal. I will ask B, sino makasabat. Let's say for example, mo tong hambal ni Jobern, example, ang imo nga na-solve nga NE is 4.6. So, ang feed plate mo, 5.6, maad ka isa. Sa choices, wala sang may decimal. Anong imo piliyon sa choices? Na feed plate location.
Base 5 miss, kay lapaw man siya gapon sa 4.6.
Okay, so if you're going to ask me, although it was not then asked to us and it was not even presented that scenario, what if the multiple choice are all whole number? Just like what you do in your statistics, you round it off to the next number. Miski point lang na siya. For example, 0.2 lang na siya, 4.2 lang na siya, or 4.3 lang na siya, hindi siya kalabot 5. Ang dason na nga whole number ang inyo nga pilion. Kay kung mag 4 lang, kulang na siya. So, dito kagid sa dason nga number. So, in our case, if the example is the feed plate location is 5.6, dapat sa 6 siya ang imo nga feed i-introduce sa 6 plate sa column. So, hindi ta mag-answer sang number nga before, but rather the next number to the value that was given to you that is in decimal. So, 4.1, that would mean that it's on the 5th plate. Your feed is on the 5th plate. Though I assume that they will not give you choices that are very near to each other. So, ang pinakalapit lang imo pilion. But should there be cases wherein lapitan na yung choices, which wala gani gakatabo, digto ka gidya sa dason nga number. Kay miski sa stat, amo na siya. Basta nagsubra na sa 1, ang dason nga number ang aton nga i-answer. Okay? Now, may question pa?
Doc, may question ko, Doc. Ang R-bar, Maddox, Doc, ay ni sa Paris, Doc.
Ang ini siya nga figure. May-ari ni siya sa Paris, equivalent lang, Josh. Hindi gidya iyan ni, I think ara si Maddox, pero hindi ko sure kung si Erbar. Kaya ang aton sa textbook naton ng ang authors, let's say, isa ka empirical equation or isa ka graph, hindi na siya among i-pair dito sa handbook. Pero certain, di Kuya Josh, nga may amo ni sa handbook. Galing wala ko di soft copies ang current edition ninyo. Pero may ari ni siya sa handbook sang equivalent. Kag amo man ni siya nga mga info ang kinanlan nyo. Go to the section on distillation. I'll try to find it if I can find the time. If I can ask for a soft copy of the 9th. Ano na gani inyo handbook? 9th, no? 9th edition na ka mo? I have one in school. I can check kung ano ni siya nga figure ini. Sa 8th edition, may ari ni siya equivalent. I just forgot kung ano siya nga figure sa handbook. But I'll try to find it. Okay, wala ko copy sa 9. Pero kung kamo may handbook na da subong, certain, gid kuya may ari ni siya equivalent sini. Kaya wala taga pag-graphical sa board. So, amo ginihin nyo gamiton. Okay, pangitaon nyo lang. And again, sa na-reiterate ko na, I've been reiterating this and emphasizing that whatever is given to you is just the minimum of, should I say, the essentials na lang gid, wala na siya damo pa nga add-on because of the limited time that we have. Even if we're facing each other, it's still what your teachers can give you is just a very little of the vast body of knowledge that is available for you just as long as you love to read. It has to come from you, that desire to learn more. Hindi pag-ilimit kung ano lang ang gin-deliver sa maestra mo na. Although I understand that it was one of the comments in my TBI that too much knowledge leads to nowhere. Okay, so I understand probably for you in your case, you see that it's already too much knowledge being leading to nowhere. But to tell you, as I have said already, what I'm giving you is just the minimum that is required. What am I trying to say here? Kulang pa ng ginhatag ko sa inyo actually. Damo pa kamo dapat mabalaan. But if you think it's already overwhelming, then I can't do anything about that, because I am just delivering what I'm supposed to deliver in the minimum sense of those who are making this program, chemical engineering, those that are even more knowledgeable than me and us. So they know better. Okay? So amo na nga kinahanglan mabasa kamo kag ang inyong handbook in next year mag-graduate na kamo, ang inyong handbook dapat hindi lang gani subong, dapat sang una pag ginaamat-amat yun na nabasa para makita nyo da ang mga wala pa gin-deliver sa inyong mga teacher. Kay kabalogig ko ya nga minimum ganyan gina-deliver sang majority sa amon. Damo pagida sang available nga wala ma-deliver sa inyo. Kung hindi nyo na pag-i-compensate, kamo ang pierde, hindi ang maestra nyo. Kay ano mala ang ma-deliver sang maestra sa kadutay nga time nga ginhatag para mag-deliver sa inyo sang inog deliver. So pangitaan nyo please sa handbook. Magsiling ko gani nga may equivalent na pangitaan nyo. Kung hindi nyo makita, then call my attention. Miss, naghamba kami aragid, hindi namon makita how. Then I will be the one to try to check from my end whether there is really no available information equivalent to what I'm providing here in to you. During our time class, wala kami honestly ginatudloan magamit handbook ya. Ang ginatudlo lang sa teacher namon sa una, si McCabe, kag si Brown, kag si Faust. Bahala ka na ya sa imo kabuhi kung paano mo na pangitao ng equivalent sa imo handbook. Even the sections where we get the properties, even the section kung diin pangwaon ng mga data, kami na iyaga pangita. Why na siya ya ginahatag sa among tag isa-isa. So we ended up being self-reliant because we know how to find our way with the minimum of assistance. So I want that also to be developed in you. Now, it would be good to ask guidance, but guidance nga daw naga-dependent na kamo knowing na sa tudod lang pila na bala inyo mga edad. Kung i-compare kamo sa previous, nag-graduate na kamo, di ba? Nga kay gindugangan pa kamo nila yung number of years o muna nagdugay ka ang inyong life nagbudlay. But nonetheless, wala tamihimo because we all have to adapt to change. So we just have to find something positive about the change. So nagdamo ng akon hamba, nagwa na ko sa topics and distillation. But ako yang gusto ko malang kamo from your end, you should develop that desire to read. Kaya na-notice ko, hindi man lang sa inyo, kalabanan sa estudyante ko, maghatag ko reading assignment, wala ga-read. Kaya laban-laban kisa sang una, sang hindi pa COVID time, tagaan ko sila sang sample problem, sa ginpabasa ko sa ila, word for word, tanan-tanan ni value the same, hindi sila kabalo. Meaning, wala sila gabasa. So hopefully, kamo, hindi, you're different than those that I have already encountered in the past. You have to really now help yourselves more. Okay? Now, so this is it. You have to use two equations in this case. That way you can find specifically the number of stages in the enriching section and in the stripping section. Now, this is the sample problem that I'm talking about. Now, this sample problem, where did I get this? I think I got this from the internet in PDF format because I have snipped it and placed it here on my slides. The solution to the entire problem is in here. It reflects the graphical It reflects the determination of the minimum number of stages using Finskis equation, as you can see here. And this is the column simplified. So the condenser was placed on top and the reboiler was placed here at the bottom. Now I'd like you to read this. This is the detailed explanation on how the minimum number of stages was determined using the alpha of the distillate and the alpha of the bottom's liquid, referring to the geometric mean of the two. So you could see that's the geometric mean, the square root of the product. And now you have the value here. So since everything is in here, that way learning will be two-way in our case. So you will have to read this on your own. If you have any problem, don't hesitate to message me if there's anything that you cannot follow through, or if it could wait, then you can ask those questions in Monday when we discuss this topic again. So before I go to the next topic, I will discuss to you any questions or any point of clarifications that you may have on this particular sample problem. Okay? Now, that's the minimum reflux there. You know why it's like that? It's because minimum reflux here, your Q line touches on the equilibrium curve, and this is your enriching section operating line. So this is your pinch point. So please read that particular problem. So you have the RM here, and that's it for this particular problem. This problem presents everything graphical and analytical. So the reason when I place it here, it's because it is now presenting both the graphical approach and the analytical approach. Okay, you ask me questions on Monday if there are things that are not clear here, but you have in your part to read this because everything is there already. Now, let's go to the special case of rectification. So these are found in Jan Kuplis. You cannot read this in McCabe. This is not provided in McCabe. And this can also be, this is actually the mix of what I have read from Jan Kuplis and from the handbook. We have this what we call stripping column distillation. It's like your column does not have an enriching section. Is there such a thing as a column not having an enriching section? That is why it's called the special case of rectification. So let me read through the bullet in here, the bullets in here. So feed, which is usually saturated liquid, normally our feed to the column is saturated liquid, is at its boiling point, meaning it's saturated liquid, is introduced at the top of the stripping column. There's no enriching section of your distilling column. You only have a stripping section. Overhead product VD, that's the vapor that is leaving the top plate of your stripping section, is the vapor rising from the top plate which goes to the condenser with no reflux. So take note, this particular type of distillation does not have any reflux liquid. All of the vapors leaving the top plate of your stripping section is being condensed. It is now fed to the condenser, everything. W, the bottom's liquid product, is rich in the non-volatile component. Now, the column operates as a stripping tower. So since it does not have any enriching section, it operates as a stripping tower with the vapor removing the more volatile component from the liquid as it flows down. So the vapor removes the more volatile component from the liquid feed that is flowing down because the vapor is flowing countercurrent to this liquid. So meaning it goes up and it carries with it the volatile component already. Now, I have placed in here the section in your handbook where you can read on this because my basis on this, I think, is John Kuplis. Now, as for your stripping section distillation or your stripping column distillation, you have this. So take note, class, take note. Your feed at all times in here is saturated liquid. So we cannot have a stripping column still if your feed is not saturated liquid. And the procedure graphically could be seen is a lot simpler. You look at it graphically. Now, your feed is saturated liquid, and if you could still recall, if it's saturated liquid, your Q is equal to 1. If your Q is equal to 1, right on the mole fraction of the feed, your Q line will be vertical. So very easy. You just draw the Q line in here right on XF, and its orientation will be vertical. Now, next is, you could see that you have YD in here. Where is this YD, Miss? Di ni namo, Miss Kwaon, si YD. Where is YD to be taken? Remember that there is no more reflux liquid. So all of your vapor is, shall I say, fed to the condenser and converted into liquid. Even if, class, there is reflux liquid that is returned into the column, remember this. The mole fraction of the vapor that leaves the top plate, which is in this case the Y sub D, and the mole fraction of the reflux liquid, and the mole fraction of the distillate, if it's normal distillation, are all equal. Why are they all equal? Recall that your distillate just came from the vapor that was condensed. So whatever is the mole fraction of the vapor, that should be the mole fraction of your distillate. And if there's reflux, that would also be the mole fraction of your reflux. So what would you do with the corresponding value of the distillate mole fraction? On the vertical column here, on the vertical axis, if you're doing graphically, project that right on your Q line that is vertical. Or you just simply go to the right and end there on the Q line that you have drawn. You have the XW here, which is the beginning of the stripping section operating line. You have to connect these 2 points. The XW that you have here and the YD that you have projected on your Q line. And that's it. The process of determining the number of stages is shorter in this case. But again, don't forget to subtract 1 because you still have the reboiler here, and the reboiler is not part of your column. Okay, so this is the case of the stripping section distillation, or a stripping column distillation, a special type of rectification. So your column does not have an enriching section. It only has the stripping section. And again, note that the feed at all times has to be saturated liquid. Hindi pwede lain ang state sang feed in this case. Okay? I will end with this next because they are comparable. So if we have what we call a stripping column distillation, we also have an enriching column distillation. So this time, wala ka naman sang dalom nga part. You have the upper part of the column, which is the enriching section, but there's no stripping section. Now, how could this be? So in this case, the feed enters the bottom of the tower. Susulian, naigid sila sang isa. So in the previous one, the feed is introduced on top of your tower, kaya wala naman siya babaw. And it's liquid. In here, the feed is introduced at the bottom of the tower, kaya wala naman siya dalom, but it's vapor. Its state is vapor. Distillate is more rich on the volatile component, just like any process of distilling. Bottom's product is comparable to the feed, meaning in terms of characteristic, but may at times be slightly leaner in the volatile component. Meaning, ang characteristics sang feed nga gin-introduce sa column kag sang bottom's liquid daw amo-amo lang. Pero kung i-compare ang composition sang volatile component that you can find in the feed and in the bottom's liquid, mas damo of course ang iya ni feed. Because the bottom's liquid may at times be having a slightly leaner composition in terms of the volatile component. As expected, we know that bottom's liquid always have the more volatile component. So in terms of the presence of the least volatile, the highest boiling component, the least volatile component. So in terms of the presence of the most volatile component, it has very little. If feed is saturated vapor in this case, the V sub N is equal to the feed. That is the vapor that leaves the nth plate in terms of, shall I say, in terms of characteristics this time is comparable to that of the feed. Enriching line and Q line equations in this case still holds. Now, I will ask and I will end with this, or the end with this. What is the orientation of the feed line when the feed is vapor? If it's liquid, it's vertical, right? If it's vapor, ano siya? What's the Q line
Higda,
orientation?
miss.
Gahigda.
Higda, miss.
Horizontal na siya.
Horizontal.
Horizontal na siya. Susuli na siya. So kung mag-drawing ka mo sina sa inyong upper portion sa curve, your Q line would be horizontal in orientation. How would you then draw or graph the enriching section operating line? It's still the same as if you have an entire column. Meaning, if it's the enriching section operating line, of course, you need the X sub D, the mole fraction of the distillate, and you should know, of course, the reflux ratio. The problem should be able to give you or should give you the reflux ratio. That way, you can now plot your enriching section operating line. When you have the Q line and the enriching section operating line plotted, you do the stepwise way of determining the number of stages as if your column is complete, meaning you start with XD down until you reach the end of your feed line. In here, in this case, you need not subtract 1 because it's the upper part of your column. Wala man tas ang may ginasubtract sa babaw. Ang ginasubtract ta is due sa presence ng reboiler sa dalong. There's a special case in which you need to subtract 2, but I will discuss that next meeting, and that would be on Monday. So for now, we will settle with this. You can read on this in the section that is indicated here in your handbook. And this would be how it's going to be. Your enriching section, distillation. There are still other types of rectification, and we will be discussing that as well on Monday. Okay? Any section, any question for now? No more question? Okay. Sige, if you will have any questions later on as you do your readings, you can just, it would be easier to ask me a question right on GC or right on Messenger because I can read it actually right away. If it's in Canvas, that is okay if I am also online. If I'm not, then I won't be able to answer it right away. Okay, so much for the day class. You have been with your unit ops for 3 hours already this afternoon, but I hope everybody did learn a lot this afternoon. So I will be hearing from you again. I will stop recording.